Hi everyone, I am Toshiki Hirao, an assistant professor of Nara Institute of Science and Technologies and the Chief Executive Officer in DTOSH Incorporation. In this presentation, I would like to talk about our journal first paper, Code Reviews with Divergent Review Scores, an empirical study of the OPENSTACK and QT communities. Okay, let's get started. This journal basically focuses on code review processes in open source projects. Before going into the main part of this journal, I would like to explain how code review processes work briefly. First of all, developers submit their patches. And second, reviewers discuss the quality of those patches. And finally, if there's no problem on those patches, they will be integrated into main repositories. In the review discussion step, multiple reviewers tend to send different comments on the patch, which may disagree each other. When reviewers send different thoughts, we call those thoughts divergent discussion. Prior work has shown that the divergent discussion may slow down the review process and create a tense environment in the project. So it is difficult for developers to resolve divergent discussion. While related work has shown the negative impact of divergent discussions, we haven't known much about how divergent discussions occurred and was resolved. In order to have much deeper understanding about divergent discussion, we performed quantitative and qualitative studies. In the first research question, we would like to know how often divergent reviews occur. In the second research question, we quantitatively studied how often divergent reviews eventually end up being integrated into their repositories. In the third and fourth research questions, we studied why divergent reviews occur and how those reviews are resolved during review processes. The first research question motivates this study by investigating how often reviews are divergent. We studied 4 open source projects. Also, we define what divergent discussion is and propose the identification approach for divergence. For example, if there are multiple reviewers who have at least one positive score and one negative score, we define the discussion as divergent discussion. Okay, so this graph shows the rate of divergent reviewers in each system. Overall, 15% to 37% of reviews are divergent across 4 subject systems. In research question 2, we investigated how often divergent reviews are integrated. We collected divergent reviews and then classified them into integrated or abandoned review groups. We find that the divergent reviews tend to be eventually integrated into codebase across 4 projects, ranging from 64% to 74%. This result indicates that even though reviewers have a divergent discussion, they are likely to resolve the divergence until the end of the discussion. In the third research question, we'd like to know what causes divergent discussions. In order to do that, we manually investigated review discussions and see the cause of divergence. We first performed random sampling from original data, and then we tagged a key reason for each divergent discussion. For this tagging, we manually read each review discussion to know whether divergent discussion occurs. And finally, we did card sorting to categorize those tags into multiple categories. We found that external dependency issues are the major reasons for divergent discussion. In details, 54% to 61% of divergent discussions are raised due to the external dependencies. External dependency is a relationship among multiple reviews. We have an example at the bottom of the slide. In this example, one reviewer might say the patch is ready for integration, while another reviewer might say the patch needs to wait for the other patch's integration first, which ends up being divergent discussion. In our research question 4, we like to understand how divergent discussions are resolved. In this research question, we try to see how discussions proceeded until the end. Hence, we see the difference between divergent reviews and non-divergent reviews. From our manual reading, we find that divergent reviews indirectly address issues more often than non-divergent reviews. For example, we find a pattern which is called withdrawal of negative scores. It means that the first reviewer says additional fix is necessary before the integration, and then the reviewer posted negative score. After that, the second reviewer posted the positive score by saying that no, it's not needed because blah blah blah. After the discussion between the first and the second reviewers, the first reviewer finally persuaded the second reviewer. Throughout our quantitative and the qualitative studies, we've gotten 4 key conclusions. For the first research question, how often are reviews divergent? We find that overall 15% to 37% of reviews are divergent in our studied projects. For research question 2, how often are divergent reviews integrated into their repositories? We find that divergent reviews tend to be eventually integrated into code bases. For research question 3, what causes divergent reviews? So we find that a lack of awareness of external activities often causes divergent discussion. For the final research question, how are divergent discussions resolved? We find that divergent reviews indirectly address issues more often than non-divergent reviews. So based on our conclusions, we suggest that developers should be aware of external dependencies to resolve divergent discussions. The rest of detailed suggestions are written in our journal. Okay, so I'd like to wrap up this presentation. This journal focuses on the divergent discussions where reviewers provide different thoughts. We find that 15% to 37% of reviews are divergent in 4 subjects projects, which means that divergent discussions are not uncommon in code review processes. We quantitatively and qualitatively studied divergent discussions and provided a variety of suggestions in this journal. And again, I'm Toshiki Hirao from Nara Institute of Science and Technologies. If you have any questions, please contact this email. Thank you very much.
Hi again. At this moment, Toshiki Hirao is today with us. He is going to answer any possible questions you may have about his great work. At this moment, we have a question from Luis Cruz. And well, first thing, he's congratulating him for your work. He says that it's a nice work. And then the question is, from the explanation of external dependencies, it seems like this is not related directly to the pull request under review, but rather to external patches. In your view, how should developers avoid this?
Okay, so
I don't know if maybe
Well,
you may want to clarify a little bit more what external dependencies are.
okay. Like first of all, I'm gonna explain what is the external dependency. So external dependency is a relationship between like multiple reviews. And for example, you throw like one review into the like code review system, but your change if your change has some part that is really depending on other component. So in that case, and then if the component is also has been like fixed by other developers, so you have to wait for the integration of other patch first. So in that case, we call it like external dependency. So you have to wait. There's a dependency between like at least more than one review, and you have to wait for other patches integration, for example. And then is Louis asking about the way to avoid the external dependency?
This is related. Okay. Maybe we can ask him for clarification. Maybe he can clarify us a little bit the question.
Okay.
Yeah.
Oh, okay, great.
So that's right. Does it mean that he has answered your question, or it means that?
Okay, so I understand. So, how should developers avoid this? So basically, my opinion is that you don't have to avoid external dependency. If it's needed, we can do anything about that. But if you need some external dependencies on your reviews, you have to be really careful about like how the discussion will work. So sometimes external dependency might create a tense environment, the tense discussion between reviewers. So one reviewer might say, "Hey, it doesn't matter for this time," but another reviewer might say, "It really matters at that time," and then that makes a really tense discussion in some projects. So I don't think there is the clear way to avoid external dependencies, but I recommend you that you should be really careful when you face external dependency during the code review process.
Okay, so he has clarified a little bit more his question, but I think you have answered it. So he says that my point is that when you ask for a review, a developer is expecting a review about its own patch. External dependencies mean that it does not have to do anything about the patch itself, but rather to external patches. How to avoid this waste of time, energy?
So my point is
yeah, but I guess that's what you answer, right? We have another question from Alexander Serebrenik. Did you observe divergent review scores leading to expression of emotion, anger, frustration, sadness?
Yes, there are some cases where divergent review was caused by like expression of emotion. Like for example, in QT system, which we've studied in this journal. So I've seen some reviews where like one reviewer is saying like a reviewer was really at anger, whereas some other reviewer is kind of like being frustrated at other reviewer. So there was actually a fight between like several reviewers. I could see it really clearly. So there are some cases. Yeah, my conclusion was that there are some cases caused by like emotion problems. But as far as I saw in OpenStack, there are a few cases in that situation. Qt communities had a lot.
Okay, thank you very much. We have now a few questions. Matteo Patengi is asking, thanks for the talk. Did you notice any significant difference among different projects during manual inspection that might motivate further work on other additional projects? Is there any community that is more prone to have divergent discussions?
Okay. Let me try to ask the first one. Did you notice any significant difference among different projects? Okay. Is there any community that's more prone to have divergent? Okay. So again, in terms of proneness to having divergent discussion, so Qt, like among the studied projects in this journal, Qt community is more prone to have like divergent discussion compared to OpenStack. I haven't looked at the detailed like observations in the Qt community yet, but as far as I saw, there's some fighting review cases in Qt communities. So as far as I remember, I put some URLs in this journal about the fighting cases, so you can take a look at those cases. And the next one is okay. So any insights as to how they?
Okay, so shall we move to the next one then? Have you finished that one?
Any insights?
So Mauricio Nietzsche is asking, any insight as to how developers actually solve these divergences in the good cases when the patch gets merged?
Yeah, so basically, like in the good cases, like the cases where like those patches eventually get merged. So those reviewers are likely to discuss like a lot to ensure that every one of them understands correctly about other people's opinions. So unless you have a like deep understanding about like everyone's opinion, it is really hard to solve the divergence. But in